Hello grade 12. Today we have a new topic, statistics, and our lesson is the correlation. Let's watch the video and start to explain the correlation.
The correlation coefficient doesn't just tell us whether two variables move in the same or opposite direction like the covariance does. It also indicates how strong the relationship is, and its value ranges from -1 to 1. As such, A1 indicates the strongest possible positive correlation. Think of it as perfect direct proportionality. If I pay you $2 for every apple you pick, the correlation coefficient between the number of apples you've picked and your apple picking earnings for that day will be 1. B. -1 indicates the strongest possible inverse correlation, or, if you will, perfect inverse proportionality. To use the previous example, if I start the day with a large pile of money from which I pay you, the correlation coefficient between the number of apples you've picked and the amount of money in my pile will be -1. And C, 0 indicates that there's no correlation at all. Formula-wise, the most popular one is the Pearson correlation coefficient, which is represented by the letter R and calculated by dividing the covariance by the standard deviation of one variable multiplied by the standard deviation of the other. Simply 1. Watch our video about the covariance. 2. Watch our video about the standard deviation. And 3. Once you understand the concepts and formulas for each, just remember that R equals covariance divided by standard deviation multiplied by standard deviation. Simple enough? The correlation coefficient doesn't just tell us whether two
Yes, the video is simple enough to understand our topic, the correlation, and the definition of correlation using the symbol R. Look right, we have a linear relation. It's a relation between horizontal variable x and vertical the variable y. So, the definition of our topic, which is correlation, is a statistical method by which the degree, attention, degree and type, two items, the degree and the type between two variables can be determined. And the types of correlation, which have the symbol R. First type, direct correlation. The direct correlation, I can't say that it's a direct correlation if I have a positive correlation. It means if I calculate the R and I get positive correlation, so it means the correlation is direct. Second type, inverse correlation. When the value of R is negative, it means we have an inverse correlation. Zero correlation when R equal 0. It means no correlation. يبقى positive, negative, and 0. Okay? El positive means it's direct. El positive, if the value of R is positive, it means the type is direct correlation. If the R has a negative value, it means it's an inverse, the type is an inverse correlation. When R is 0, it means no correlation. Let's tell you some examples for each type. The direct correlation or positive correlation, each of the two variables increase or decrease by the other. If the first variable increase, the other one increase. If the first variable decrease, it means the other variable is decrease because they have a direct correlation. And for example, the correlation between the wage of worker and the period of his experience. Since the experience increase, sure, the salary will and the income will increase. On the other side, the inverse correlation. When the R is has a negative value, it means we have an inverse correlation. Inverse means when one of the two variables increase, the other decrease, or the first decrease, the other increase. If the two variables increase or decrease by the decrease or increase of the other. As, for example, the correlation between training hours on typewriter and the number of errors in typing. If I spend more and more for training, it means I will be perfect more than the start and the error will decrease. يبقى training hours increase, errors will decrease. The correlation coefficient using a symbol R, it measures how much the two variables are correlated. And the most famous type of correlation is Pearson's. Pearson's correlation coefficient has a formula n sum xy. That sign looks like number 4, okay, or sorry, number 3. N sum, we read it as sum. N sum xy minus sum x multiply sum y over root n sum x square minus sum x all power 2 multiply n sum y square minus sum y all power 2. There is a difference between y square and sum y square and sum y all power 2. Let's see. Where n is the number of values. And properties of correlation coefficient. First property, R is positive in case of the direct correlation and the negative in case of the inverse. يبقى positive 1 يبقى a relation direct, negative 1 it's inverse. And the correlation, the value of R lies between negative 1 and 1. The correlation value lies between negative 1 and 1. Number 2, tell us about the value of R. Number 3, tell us about the degree of correlation. Zero correlation if R equals 0, first degree. Second degree, weak correlation when the absolute of R less than 0.4. الابسوليوت هنا means whatever, positive or negative. يعني for example, positive 0.4, the absolute is 0.4. Negative 0.3 is absolute. Negative 0.3, it will be 0.3. So the type is weak if the absolute of R is less than 0.4. Medium correlation if the R lies between 0.4 and 0.6. Again, 0 correlation. Less than 0.4, weak correlation. Between or greater than or equal 0.4 and 0.6, it's medium. But if the R greater than 0.6 and less than 1, strong correlation. Perfect direct correlation when R equal to 1. Perfect inverse correlation when R equal negative 1. 0, weak, medium, strong, perfect direct, perfect inverse. 0 when R equals 0. Weak when the absolute less than 4. Medium when the R lies between 0.4 0.6. Here we have to write the absolute. Strong when the absolute R less than 0, greater than 0.6 but less than 1. When R is 1, it's perfect direct. When R negative 1, perfect inverse. Let's solve the first example. Calculate the correlation coefficient. I'm going to give you a simple table consists of 2 rows. First row, value of x. Second row, values of y. Since we need sum of x, so sum of y, and some x squared, some y squared, some xy, I'm going to draw a table consists of 1, 2, 3, 4, 5 columns. First column, values of x. Second column, values of y. Third, x multiply y, each value of x multiply the corresponding value of y, x, y. Third column is x squared. Square each value in x column, and last column is y squared, square each value in y column. And at the end you have to find the sum of x, sum of y, sum of xy, sum of x squared, sum of y squared. Again, I'm going to plug 10, 7, 8, 7, 6, 4 in the first column as values of x. Plug 5, 8, 7, 9, 9, 10 in second column as values of y. And then I'm going to multiply it 10 by 5, 7 by 8, 8 by 7, 7 by 9, 6 by 9, 4 by 10. And sum. X square, 10 square, 100, 7 square, 49, 8 square, 64, 7 square, 49, 6 square, 4 square. And then the square of each value in y column. 5 square, 8 square, 7 square, 9 square, 9 square, 10 square, and then the sum. Now we are going to substitute each variable here by the sum. First, we said that the r equal n, which the number of values. Let's count 1, 2, 3, 4, 5. We have 6 values. And sum xy, which is 319, sum x 42, sum y 48. Between them it's multiplying operation. Down root n multiply sum x square, n number of variables. Sum x square, where is sum x square? Yes, 340. Minus sum x all bar 2. There is a big difference between sum x square and sum x all bar 2. Sum x here, first column, is 42. Multiply root in sum y square minus sum y all bar 2. First root, under the first root, variable x. Second root, variable y. But the same root in sum y square minus sum y all bar 2. By substitution, n replace n 6, sum xy 319, sum x 42, sum y 48, and root sum n sum x square 6 times 314 minus 42 times 42, because it's a sum x bar 2, and similar for the other root 6 multiply 400 minus 48 times 48. Using your calculator you will get the value negative 0.59. Since the value of r is negative, it means we have an inverse correlation. Since we have negative 0.59, the absolute is going to be 0.59. Is it weak or strong? Yes, it's strong. Strong inverse correlation because it's greater than 0.4. Thank you, grade 12. See you later, inshallah.